Test, test. Okay, hello everyone, welcome to the OneClass channel. My name is Andrew and I'm currently doing stats and math at University of Toronto. Today we'll be going over some commonly asked mathematics questions at both the high school and college levels. And if you need some homework help or tutoring, please check out the links in the description below. So now let's start our session. Okay. So our first question today is asking us, what is root 65? Okay, so now let's copy down the question first. So, what is root 65? All right, so first, we can always express this by its product of its prime numbers. So whenever we come across a question asking us what is root something, so we always express the value as a product of its prime factors. So let's write down the keyword. So product of its prime factors. Okay, so we know that 65 is equal to 5 times 13. Yep, and we know that 5 and 13 are prime numbers. Okay, so now we can go to our second step. We can apply the radical root. Okay, so we have root 65 is equal to root 5 times 13. And in this case, we cannot further exact any root since we don't have a pair of same factor. So let's mark it down here. Cannot further extract any root since we don't have a pair of same factor. Alright, so our last step, we can write our conclusion. So therefore, root 65 is already in its own simplest radical form. Yeah. And let me just explain this part a little bit more. So what I mean by they don't have a pair of same factor is that recalling the property, if we got a root square of, let's say, a squared, and the answer for this part will be a, right? So for example, let's say if we have root 3 squared and then we take the square root out that, we're gonna get 3, right? So let's say we got a root square of 100 squared and then we'll get 100 as our answer. Yeah, so that's what I mean by a pair of same factor, because this can also be written as root 3 times 3, root a times a, and root 100 times 100. Yeah. Okay. And yeah, so root 65 is already in simplest radical form. And now let's look at the Janine Tutor's answer for the second part. So it says we can still estimate the value of root 65 without using any calculator. So in this case is that we need so whenever we're asking to convert this root 65 into a decimal form, and that should be the method we're going to use. So we know root 65 lies between two perfect square roots, which are, let me write it on here, which are root 64 and root 81. And the reason why we're picking these 2 points is because root 64 is actually 8, and root 81 is actually 9, because 9 times 9 is equal to 81, and 8 times 8 is equal to 64. So therefore, we can represent that on a horizontal line, which is 8, 9, and let's say that's 8.5. So this part is also root 64, root 81. And we know that 65 is what we're looking for. And let me write this down. So, wait. Yeah. Okay. So, root 65 is what we want. And 65 is just only 1 unit away from 64. And 16 unit away from 81. Yeah. So based on the plotted points, we can estimate the root 65 is between 8.0 and 8.1. So let's write 8.0 to 8.1. Yep. So let's try 8.01 square. So 8.01 square. So that should be equal to 0.1 square. So 64.16.1, and then we keep calculating 802 square, which is 64.3204, and all the way to 8.06, which is 60.9638. And 8.07 square is equal to 65.1249. So now we realize that our second to the last product is the closest to 65, so we can conclude our answer. So therefore, root 65 is approximately equal to 8.06. Yeah. Okay. Oops, and that is 8. Yeah, so that's all we got for this part. Yeah, so let's leave a comment. Solution is correct. Good job.